morning, everyone. My name is Emil, and I am delighted to present to you today on the topic algorithms versus models in machine learning with a focus on unsupervised learning. We will explore how these components differ, their roles in processing data, and how they work together to uncover patterns in unlabeled datasets. Let's begin. Firstly, we will start by introducing you to unsupervised machine learning. Unsupervised machine learning is a fascinating field because it operates without labeled data. So its definition will be like machine learning without labeled data. Its primary goal is discover hidden patterns and structures within datasets or in data. Some practical applications include customer segmentation, dimensional reduction, and anomaly detection. For instance, clustering helps businesses group customers based on behavior, while anomaly detection identifies unusual activities in systems like fraud detection. Key concepts in unsupervised learning. In unsupervised learning, we deal with unlabeled datasets, so our data will be unlabeled datasets. This involves focusing on three primary tasks: identifying groups through clustering, reducing complexity, and simplifying complex datasets with dimensional reduction, and detecting outliers or finding anomalies by using anomaly detection. Each task opens new possibilities for data analysis and discovery, paving the way for innovations in numerous industries. Unsupervised machine learning algorithms form the foundation of unsupervised learning. They are the logic for uncovering patterns. There are three key types of algorithms: clustering methods like k-means, dbScan, dimensional reduction techniques such as PCA, TSNE, anomaly detection approaches like isolation forest. Each serves a distinct purpose in pattern discovery. Clustering algorithms. Clustering algorithms purpose is group data points based on similarities. So they group similar data points together. For example, Kaimis clustering algorithms identifies clusters by iteratively assigning points to the nearest centroids. So its short definition will be iterative assignment to centroids. dbScan focuses on density, forming clusters of arbitrary shape, which is particularly useful in irregular datasets. Finally, uh, hierarchical clustering uses dendrograms to create nested groupings, giving us a detailed view of the data structure. So its short description will be like dendrogram based grouping. Let's continue with dimensional reduction algorithms. Their purpose is simplify data while retaining important information. So they simplifies high dimensional datasets while preserving essential information. PCA is widely used for projecting data onto principal components, reducing dimensions with minimal loss of variance. TCNA, on the other hand, is great for visualizing complex datasets in 2 or 3 dimensions, making patterns more accessible. And in the end, UMAP preserves global and local data structures, means but it balances both local and global structures, making it a favorite for visualizing biological data. So let's continue with anomaly detection algorithms. Their purpose is identifying rare or unusual data points. Anomaly detection is vital for identifying rare data points that divide from uh, the norm. Isolation forest, for example, isolation forest isolates anomalies based on shorter passes in randomly constructed trees or based, so it isolates anomalies based on random splits. One class CVM, however, defines a boundary around normal data and flags anything outside as anomalies. These algorithms are integral to fraud detection, system monitoring, and cybersecurity. Let's define unsupervised machine learning models. Models are the outcomes of uh, training algorithms. When an algorithm processes data, it produces a model. A model represents the patterns or structures discovered by the algorithm. For example, clustering models consist of centroids, while dimensional reduction models transform data into lower dimensions. These models can then be applied to new unseen data for inference. Let's start by clustering models. Clustering models are outcomes of clustering algorithms. For example, a Kami's model outputs centroids that define or represent clusters. These centroids allow us to categorize new data points based on proximity to the clusters, making it useful for customer segmentation or recommendation systems. Let's proceed with dimensionality reduction models. Dimensionality reduction models, such as those produced by PCA, help us um, reduce the number of features in a dataset while retaining its core structure. These models are particularly useful for visualization and as processing steps before applying other machine learning techniques. Let's proceed with anomaly detection models. Anomaly detection models use thresholds or rules to flag outliers. For example, isolation forest model identifies anomalies based on unique decision paths. Such models are critical in fields like finance and healthcare, where identifying outliers can prevent fraud or signal potential issues. As I said, these models is used for cybersecurity. Key differences. Key differences between algorithms versus models. Algorithms and models serve different purposes in machine learning. Algorithms are processes for analyzing data, while models are the outcomes representing the patterns found. For instance, a clustering algorithm like Chime's produces a model with clustered centroids. This distinction is key to understanding how machine learning operates. By the way, as you can see, algorithms is the logic for analyzing data, but models is the output that represent patterns. Their purpose is different from each other. Algorithms is used for discovering patterns, while models is used to apply patterns to new data. Okay, let's continue. Workflow in unsupervised machine learning. The workflow in unsupervised machine learning involves several steps: inputting labeled unlabeled data, selecting an algorithm, training the algorithm to find patterns, generate a model, and finally using the model for inference. This structured approach ensures consistency and reliability in uncovering insights. Okay, let's continue with applications of unsupervised learning. Unsupervised learning is incredibly versatile. Clustering is used for market segmentation and image comparison. Dimensional reduction helps visualize large datasets and prepare data for supervised learning. Anomaly detection plays a crucial role in fraud detection and network security, highlighting its real-world impact. Advantages of unsupervised learning. The primary advantage of unsupervised learning is its ability to work with unlabeled data, which is abundant in the real world. It excels at identifying hidden structures, reducing data dimensionality, and detecting anomalies, providing invaluable insights across industries. Challenges of unsupervised learning. However, there are challenges. Without labels, evaluating results can be tricky, so it's hard to evaluate results. Unsupervised learning is also sensitive to data quality, requiring careful processing. Additionally, computational costs can be high, particularly for large datasets, and there are no clear labels for validation of the data. So let's look at the best practices to maximize our success. To maximize success, it's essential to pre-process data by normalize and cleaning it carefully. Select algorithms suited to your datasets and validate results using domain knowledge or external criteria. Experimenting with hyperparameters can also enhance model performance. As a conclusion, unsupervised learning provides unique opportunities to analyze and understand unlabeled data. So it reveals insights from unlabeled data. The distinguish between algorithms and models is fundamental for effective application. With continuous advancements, its potential applications, I mean algorithms and their applications, will only continue to grow. And here you can see my references. I used data camp introduction to unsupervised learning blog and Java Point, GX for Geeks, IBM, and I used Jaron's hands-on machine learning with scikit-learn, Keras, and TensorFlow book. I used page 259 up to 294. And in the end, thank you for your attention, and you can reach out to me to ask your questions.